lesson 11-5, piecewise functions. Let's take a look at some definitions for this particular lesson. An interval is a set of numbers for which we can observe, graph, and evaluate any function. Let's take a look at how intervals are written. You want to write down these examples of how intervals can be written. The key one is the last example that we have there, because this may or may not be something you've seen before. We have two inequality signs involved with that particular interval. When we have two inequality signs, we're talking about the numbers that end up between the two numbers on the outsides. The other main point to remember here is that the inequality signs that have a bar underneath them include the number that is before or after them. If there's no bar underneath, it does not include the number that is before or after them. This all leads us to our definition of a piecewise function. A piecewise function is a function with multiple subfunctions, each that has a different domain that's defined by an interval. Let's take a look at what a piecewise function looks like. It is one of those uglier things in mathematics that all of a sudden some students seem to get very frightened over. But it's not that big of a deal. Let's take a look at this and see if we can interpret it. The first thing to notice is that we have two subfunctions here. The first subfunction I'm going to underline in blue. This subfunction is defined as f of x is equal to negative x. Now, a couple of reminders here for you. Remember that f of x is simply just a fancy way of writing y. The second thing is that taking a look at this particular interval. This interval says x is less than 0. That means that the numbers that will go with this part of the function are all numbers that are less than 0. And 0 is not included because of a lack of a bar on the inequality sign. The second function I'll underline in red. This function is f of x equals x. And that part of the function will be defined when the x value is greater than or equal to 0, meaning all numbers above 0 and including 0. Recapping, again, this means that for any value where x is less than 0, we're going to use the part of the function f of x equals negative x. For any value where x is greater than or equal to 0, we'll use the function f of x equals x. The two things that we can do with piecewise functions are evaluate them and or graph them. Let's take a look at how we can evaluate piecewise functions. To evaluate a piecewise function, the first thing you want to do is determine which piece of the function that you want to use. Which of the subfunctions are you going to use for the particular value that you're given? Next, use that subfunction or piece to find the value of the function. Let's do a guided example. Let's evaluate the following piecewise function with two separate values, f of negative 3 and f of 4. Let's do f of negative 3 first. According to my piecewise function, I have two parts. One part is when x is less than negative 2, and the other part is when x is greater than or equal to negative 2. For f of negative 3, I'm going to use the top part where x is now less than negative 2. So for f of negative 3, I'm going to use the function I'm underlining right now, negative 3x plus 5. So f of negative 3 is equal to negative 3 times negative 3 minus 5. When I evaluate that, negative 3 times negative 3 is a positive 9, minus 5 is 4. Therefore, f of negative 3 is equal to 4. For f of 4, we're going to use the bottom piece of the piecewise function because 4 is greater than or equal to negative 2. That means I'm going to use this function I'm underlining in red, 2x squared. So, in this case, f of 4 is equal to 2 times 4 squared. When evaluating that, I square 4 first, which is 16, and then multiply it by 2 to give me 32. So, for this function, f of 4 is equal to 32. Here's an example for you to try. Pause the video at this point to give yourself a chance to do it on your own. For f of negative 4, we're going to take care of the top piece function, the one I just underlined in purple, because negative 4 is less than negative 2. So f of negative 4 is equal to negative 6 times negative 4 plus 1. Negative 6 times negative 4 is a positive 24 plus 1, which is equal to 25. So, f of negative 4 is equal to 25. I'm underlining the f of 0 function in light blue. That's the middle function because 0 is between negative 2 and 2 inclusive. So, for this particular one, we have 0 squared minus 3, which is equal to 0 minus 3, which is equal to negative 3. So, f of 0 is equal to negative 3. For the last one, I'll do it in orange, and 5 is greater than 2, so we'll plug it into x minus 8. So 5 minus 8, which is equal to negative 3. And that's okay to have the same value for two different functions because of the fact that it's two different pieces of the function. So f of 5 is also equal to negative 3. Let's discuss graphing piecewise functions. First, a point of discontinuity is a point on the graph where the graph changes from graphing one of the subfunctions to graphing one of the other subfunctions. A point of discontinuity is one of two things. It's either an open circle when the value is not included, or it's a closed circle when the value is included. To graph a piecewise function, the first thing you want to do is create tables for each function using the given intervals. You should start with the points or point of discontinuity and choose open or closed depending on the inequality sign. Then, you should move in the direction of the inequality sign. Next, plot your points from each of the subfunctions on a set of axes, the same set of axes. Then, connect the dots where necessary and be sure to watch out for your points of discontinuity. Let's do a guided example together. Pause the video at this point to give yourself a chance to write down the instructions, the tables, and set up graph paper. So let's start with the first piece of the piecewise function, the top subfunction, negative x minus 2, when x is less than negative 2. So I'm going to start at negative 2, and I'm going to fill in my f of x values. what I have here, when I fill in these values, negative 2 is 2, minus 2 is 0. Negative 3 is 3, minus 2 is 1, so on and so forth. Then I can go and plot these points. The first thing I need to do at negative 2, since it's not inclusive in the top subfunction, is that I need an open point of discontinuity. So at the point negative 2, 0 is going to be an open circle. And I need to do a little bit better job with that one. Probably accentuate it like such. Sorry for this, the one that's in the front there. Then I can do other points here. There's negative 3, 1. There's negative 4, 2. There's negative 5, 3. Negative 6, 4, and so on. And so what I'm doing here is this. Then from my open circle, I am going in that direction, and it is continuous in that direction. So we will have an arrowhead there. Then from the second function, which is 2x squared, when x is greater than or equal to negative 2, we'll plug those values in. So this, in this case, is going to be 8. Then we have 1 squared is 1 times 2 is 2. This is going to be 0. This is going to be 2. And this is going to be 8. I want to encourage you to do this in different colors as well. It will help you out with this. So for this particular one at negative 2, we want a closed circle at 8 because it is inclusive of negative 2 this time. Okay? So then we have negative 1, 2, 0, 0, 1, 2, and 2, 8. And then we will start drawing in this direction. And we have a parabola here because it is a squared function. And our arrowhead will only be on this side because it's not continuous at the point negative 2, 8. So we only have one arrowhead here. Let's try a graphing example on your own. Pause the video at this point to give yourself a chance to try it. So the first thing I did was to set up 3 charts. My one to the left, all the way over, is going to be for this particular function, the top function I'm underlining right now in purple. And I'll find the values for that. This is going to be, when I put them into my calculator, we are going to have 5, 7, 9, 11, and 13. Keep in mind that when we're taking a look at this, that there is no bar underneath that sign. So we'll start at negative 2, 5, and we will have an open circle at negative 2, 5, followed by negative 3, 7, negative 4, 9, and negative 5, 11. Oops, I mismarked that. Start over again. So we have this, followed by 5, 7, 9, 11, and 13. So we have negative 2, 5. That one I had correct. It's going to be an open circle there. Now we're good. Now we're going to be up to 7 here with negative 3. And we have negative 4, 9. And we can't do any more points. So since it's a continuous function from that point, we will draw it in that direction. Next one I'll do is in blue. It's the middle one. It's inclusive of -2 all the way up to 2. So we have x squared minus 3. So what we have here, this is going to be a quadratic. So we have 1, -2, -3, -2, and +1. So here with -2, 1, we're going to have a closed circle there. Okay? And -1, -2. There's my point. 0, -3. This one here. And we have also another closed dot at 2 because it's inclusive of 2. 2, 1. Oops. This one right there. Make sure you make your closed dots, your closed circles nice and big. And so I'll have this here, and no arrowheads here because it's just that interval. We've restricted our interval there. And then the last part here, non-inclusive of +2 here for x minus 8. So this is going to be, I'm going to do this one in green, -6, -5, -4, -3, and -2. So the big thing here is that we need an open circle at 2, -6, which is right there. That's an open circle. And then the rest of these will be inclusive closed circles. And so from there, we will draw and connect our dots. Be using a ruler, please, when you're doing this. And we have our arrowhead. If you're having any issues with this particular lesson, please make sure you consult your teacher in class.